All right, so example 6. Here we go. What does this green vector represent? Horizontal velocity, initial or final? Initial and also final. It's the same thing, right? That's the x component. Right? What does this blue vector represent? What is it? The y component. Right? Now, typically when we do problems like this, we need to figure out the x direction and the y direction, right? So I know someone will start making lists in the x direction. So, Kevin, want to give me a rundown of your x direction list one more time?
E final is 10 meters.
Right,
E
final.
initial is 0.
The initial is 0.
Acceleration is 0.
Acceleration is 0.
And velocity and time are constant.
And I used the wrong color. Should have used green. How about that? Alright. Now, this V, that's a question mark, that's this Vx right here, right? Right? In the y direction, what do we know? We started this out. Victor, you had something to start out with. What was that?
Velocity equals 0. Velocity initial. Acceleration.
Yes. Do we have initial y velocity?
Yes.
Yes, right? There's a vertical component to this triangle. So we have an initial y velocity. You said acceleration. What's that, Victor?
Negative 9.8.
Good. Acceleration is negative 9.8 meters per second. Do we know initial velocity? We know initial velocity? No. Is there anything else we know?
Distance final is 0.
Distance final is 0. V final is 0. Right? What else? What else do we know? D naught is 0. Good. What else do you need to know? Time, do you know? So we need to find an equation. I think I made a 2-equation problem. Okay. Any questions about our 2 lists? Any questions? I'm trying to give you something here. That's very good. Alright, we can do it. Okay, I'm in a little quandary here. There's a way we can do this problem. However, it is not a problem that I would ever assign to you in the test. So would you guys like me to add a piece of information, or do you want me to do this problem the way it is?
Supposed to do number 6.
The way it is? Okay, we'll do it the way it is. All right. So for the x direction, we know that v equals v naught plus dt. Well, that's not what we want. Okay. D equals d naught plus vt, right? Right? D equals d naught plus vt. D naught is 0, right? D is, over here. D is 10. D naught is 0, right? Right? Now this V, is this X or Y? X. Okay. So We know 10 equals vt. We can divide both sides by t, and we end up with, oh, sorry, I don't want to divide by t. I want to divide by v. And we end up with 10 over v equals t. Does that make sense? Does that make sense, guys? Okay. Now, this v right here, is this x or y? That's x, right? That's x. Right? Vx equals our total velocity times what? Cosine of 55. So here we have 10 over our total velocity times the cosine of 55. Can we simplify that at all? What's cosine of 55? 0.57. So we have 10 over 0.57 v, right? Equals t. Does that make sense? Does that make sense, guys? Yeah? Okay. Can I simplify 10 over 0.57? Yeah, what does that equal? What is it? 17.5. So 17.5 over v equals t. And that's in the x direction, right? Now, if that's the time in the x direction, does that apply to the y direction? Does that apply to the y direction? Okay. So that means I can take what I know for my time in the x direction and apply it to the y direction. So now I know this t right here is 7.5 over v, where v, this is my actual total v. It's not my y or my x, it is my velocity initial. Right, does that make sense? So now I can take that and we can plug into equation 3 from over there. Okay. Equation 3 says this. D equals 1/2 at squared plus v naught t plus d naught, right? What are these two d's? Zeros. So you start on the ground, we end on the ground. 1/2 times negative 9.8 t squared plus v naught t. Oh, no. We don't know v naught. Sorry. And this v naught, is it in the x or the y? The y, right? Those that are taking Spanish, this is not voy. I'm not saying we're going somewhere. Nope. We use the x direction to figure out a time, right? This time is an equation where this v right here is our overall velocity, not our x component or our y component. Okay? Now we're going to plug that in here in a second. And we'll do that in a moment. Okay? But I want to simplify this a little bit first. And this is why it's a problem I would never assign for you guys on the test. If this were a test question, I would have given you the time. That's an oversight that I made, so sorry about that. So, 1/2 times negative 9.8, we know it's negative 4.9. Right? Now in the y direction, we know this is what of the final velocity. Or sorry, not final velocity. V naught y is what component of the actual velocity? The vertical component, right? So we know v naught y is really v, not cos, sine, right? So I can write this as 0 equals negative 4.9 t squared plus v sine 55 times t. Now some of you might see something that's in both here. What's something that's in both components here? T. I can take a t out, can't I? Right? So I can factor a t out and wind up with this. T times negative 4.9 t plus v sine 55. Oops, grab my sign. Right? Is there any other way I can simplify this? Is there any other way I can simplify this? Sine 55, right? What's sine 55, Richard?
17.5 or 385 times.
Sine 55 is 0.17?
17.5.
Are you in radians or degrees? Degrees? Sine of 55 is not 17.5. What is it? 0.819. Okay, does that help? Okay. Now we know this expression equals 0 at 2 different times, right? What's one time this expression equals 0? When what's 0? What? When t is 0. If t is 0, right? Set my first factor equals 0. That's one solution, right? The other solution to this expression occurs when this equals 0. Right? Now some of you are saying, whoa, 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 we have two variables there. We have two variables, don't we? But we also know that time equals 17.5 over v. Right? So I can take and I can do this. Negative 4.9 times 17.5 over v plus 0.819 v. Right? Still with me? Okay. So now, can I simplify this at all?
You can cancel the v.
We cannot cancel the v because they're added, they're not multiplied, Richard. Okay? You're hoping for an easy way out there, weren't you? Okay. Negative 4.9 times 17.5. What is that?
Exactly 85.7.
Exactly 85.75134. What? Really, what is it?
Negative 85.75.
Negative 85.75. Okay? Over v plus 0.819 v, right? Any bright ideas on what we should do next?
Minus 0.893. What? That. Right there, next to your face.
Yeah? Subtract that from both sides? I like your reference there, right next to your face. So we have negative 0.819 v equals negative 85.75 over v. Any other bright ideas? Trying to solve here. We cannot cancel the v's.
Times the v.
We can multiply by v, right? Some of you are saying, why would I multiply by v? Well then, like Moses suggested, it'll cancel some v's. Right? And now these two v's become v squared. So negative 0.819 v squared equals negative 85.75. What do I do now?
Square root.
Divide by negative 0.819. So v squared equals 85.75 divided by negative 0.819.
Is this a college problem?
That's just one I made to send to be a little more difficult than I expect. What do we get now? I know it'll be positive. 104.7. What should we do now, Moses?
Square root.
Square root. What's our velocity?
10.23.
So there is the initial velocity. Nothing terrible. We're just half of it. Any questions about that? There's the initial velocity. Yes.
Mr. Branch, how did you get negative 85% space?
Negative 85.75. That was negative 4.9 times 17.5.
Is this going to be on the test?
No, you weren't listening, were you? I said this one is much more difficult than one out to give you on the test.
So it's not going to be on the test?
No, it won't be on the test.
What about the exam?
No, it won't be on the exam. Yeah. In this problem, if I were to give you one like this on the test, I would actually give you the time value. Okay? So, the next part of this problem says, will it make it over a 3.5 meter tall house, right? Well, where would the best location to put the house be? In the middle, right? So we know this launch velocity right here is 10.23, right? So we know this launch velocity right here is 10.23. If we want to make it over the house, we put the house really skinny right here in the middle, right? Right? And how does that compare to the total time of the trip? Half, right? So this is half of total, right? That doesn't make any sense. Right? So equals half the total time, right? Yeah? Okay. Can we figure out how long this trip takes? How? We substitute the v in. Where? So down here. 17.5 over v equals t, right? Right? So if we substitute in our v right there for the 17.5 over v equals t, we can figure out how long this trip takes. Okay? I would have gone a different route, but that works perfectly fine. Let's do both and check. So 17.5 divided by v, what's that? Our v we said was 100 or 10.23.
1.71.
So 1.71 seconds. Right? 1.71 seconds. You get a bigger camera. Okay.
Yes.
Okay. Another way we could have done this is we could have figured out the x component, right? Vx equals v cosine 55, which equals 10.23 times the cosine of 55. What's 10.23 times cosine of 55? Anybody know? 5.86. Right? And then it goes 10 meters, doesn't it? So can we figure out how long it takes for 5.86 to go 10 meters? Right? D equals D naught plus VT. 10 equals 0 plus 5.86T. Divide by 5.86. What's 10 divided by 5.86? Is it 1.71? 1.74. So you can call them both 1.7, right? And the reason why those are a little bit different is because of rounding. So that means that this highest point occurs at half of 1.7, right? Half of 1.7 is 0.85. Right? So now we need to figure out the height at 0.85 seconds. So we're in the y direction. We know acceleration is negative 9.8 meters per second. Oh, we have the list over there. What am I doing? So we're in the y direction. We know acceleration is negative 9.8 meters per second. We know v naught, it's no longer a question mark. It's going to be 10.23 times the sine of the angle right? D final is what we don't know. And our time is half the total time, which is 0.85, right? Does anybody know what 10.23 times sine of 55 is? 8.38. Okay. So what equation should I use to figure out the final height at half the time? 1, 2, 3, 4, 5, 6. Which one?
4.
Nope. What equation do we use in the y direction? 3. And this part is more like a problem I would assign for you. Oops. Got ahead of myself. You know, it's the end of the problem. 1/2 at squared plus v naught t plus v naught. So now we can plug in what we know. D final equals 1/2 times negative 9.8 times 0.85 squared plus v naught, which we know is 8.38 times 0.85 plus 0. Can we figure out the height at 0.85 seconds? Kevin, you look mesmerized. Yeah? Can we figure out the height at 0.85 seconds? What is it? 3.58 meters. How'd you get that? Plug it all in, right? So will it make it over the house? Yeah. The only thing I would assign, guys, would be imagine that we know the time. And that's what I would assign. So this last part is more like the problem I assigned. So nice job, guys. Thanks for working through that tough problem.